remember from step 1 that we were able to write our first algebraic statement. 2a plus 3a is 5a. And we hopefully are comfortable now with the idea that we can work with things called a or b or x and do some maths with them. But why? Why would we want to do this? Aren't we just making things more difficult? But before we ask the deeper questions, let's just have a go at a few questions in our workbooks to make sure that we understand how to do these. So copy these into your exercise book, one at a time, and as you write each one, simplify the expression. Okay, so working in my exercise book, here's how I'd like you to work. So it's question 1a, write the original algebraic expression. Then we're going to use our special symbol in mathematics, the equals. And now we're actually going to do something. 3v's plus 8v's, well, that's 11v's. Leave a space. Let's do my next one. 8u plus 9u, 17u's. And so on. So notice that I don't copy all the questions first. I copy one question and do the answer. Then the next question and do the answer. And writing the whole thing with an equal sign is very important. All right, well, let's see how you went. Let's mark our answers. Hopefully your book looks a bit like mine, actually looks quite a bit like mine, where you can see all the setting out. So 11v, 17u, 15h, 10n, and 19x. Please mark your questions. 13r, 12f. Oh, this one was a tricky one. Did you notice there was no number in front of that? It was just 8t plus t. Now, maybe you worked out that is the same as 1t. We'll talk about that later. So the answer to that one was 9t, 10q, and 7e. All right, I'm just going to say one more thing about this exercise. Notice how we're writing our pronumerals. We're using kind of a cursive writing. Very important that you write a T like this, not like this, because if you write a T like this, it looks like a plus. It's important that you write your X like this, because otherwise it looks like a multiply, which we don't want. And a Q is really worth writing with a little hook like that. Otherwise, it could look like a 9. Well, I think now we deserve an answer. Why should we use pronumerals? There are quite a few reasons why we would want to use pronumerals. Here's the first one. If we want to solve various types of problems. So in this case, we can see 2 boxes of Smarties. We don't know how many are in there, so we're going to call it 2 lots of X. And we actually know it adds up to 30 Smarties because we can balance it and counter it. So the question there is, what is the value of X? What we're trying to do is we're trying to solve. That's the word that we use. We're trying to solve, find a value to find the X. A second reason we want to use pronumerals is if we're given a formula for something and we want to work out what the answer is. So for example, I might have the base of a triangle, that's 3 units, the height of a triangle, that's 4, and I'm going to use this special formula, half base times height, which you might know is going to give me the area. So this is an example of using some algebra, half base times height, which is a formula, putting values into it to get an answer out. And we call that substituting values in. We also use the word evaluate. I'm going to evaluate an expression to actually find out what the number is. A third reason for using algebra is to describe numeric patterns and relationships. So if we're watching a space shuttle taking off, or subatomic particles colliding in a cloud chamber, or a cat twisting and falling as it lands on its feet, algebra is a language that we can use to describe how these things work. And last but not least, mathematicians have discovered many amazing and incredible things. This is an image of something called a Mandelbrot set, a truly astounding diagram. And in fact, it turns out it's described by the simplest of algebraic relationships. So this gives us 4 reasons why we might want to use algebra: to solve problems, to substitute and find values, to describe the world, and to describe mathematics. 4 pretty important reasons. Algebra is a language. It's a very important language. It's a language used in science, technology, economics, business, engineering, and medicine, amongst other things. The modern world runs on algebra. In recent years, algebra has done some pretty amazing things. A few years ago, we got to see what Pluto looked like for the first time ever, an astounding image. And I would argue that this picture was brought to you because of algebra. And today, of course, algebra is very much in action. Mathematicians are eagerly studying and modeling these curves to try and work out what the best response is to COVID-19. Algebra in action.